Hey everyone, thanks for checking out the notes today. Today we're going to talk about rates of change, and then tomorrow we'll talk about tangent lines. Our objective today is to be able to use the limit definition of derivative to find the slope of a line tangent to a curve. If you remember from your geometry days, tangent means it touches the curve at exactly 1 point. So our opening questions here, just before we get started with the actual notes. What is the slope of the secant line to the function f of x equals 2x squared plus 3 that passes through the points 1, 5, and 2 and 3, 21? This question might look confusing, but really all it's asking us here is the slope between those 2 points. Okay, if you remember from your Algebra 1 days, the slope formula is y minus y over x minus x. So in this case, it's 21 minus 5 over 3 minus 1, or 8. So the slope of the line that passes through those 2 points is 8. Slopes of secant lines are called average rates of change because we're using 2 points. So we're finding the average slope between those 2 points. Second question here, what's the slope of the secant line that passes through these 2 points? It's the same problem as the last problem. It's just giving us 2 points, and we're asked to use the slope formula again. So we can grab our slope formula if needed. And again, it's just y1 minus y2, or y2 minus y1, doesn't really matter, over x minus x. All right, we can do very little simplification here. The numerator, we cannot simplify anything. You cannot distribute f, by the way. F is the name of a function. You can't distribute a function. But in the denominator, we could do x minus h minus x, x plus h minus x. The x's will cancel out, so all's left is h. Okay, so this formula right here that we just came up with, I'm going to highlight it because it's super important. It has a special name. It is called the difference quotient. I hope you can spell quotient correctly. So why is it called a difference quotient? Because in the numerator, you take a difference, and then when you divide, you get a quotient. So it's the difference quotient. So the big question here, and this is where pre-calculus turns into calculus. And this is where next time when you take calculus here, you'll learn the big difference between algebra, algebra 2, pre-calculus, and calculus. Okay, we don't want a secant line. Secant line doesn't really help us in the real world. A tangent line helps us in the real world. We don't want to know the average slope between 2 points. We want to know the exact slope at an exact point. Okay, so what we can do here is we can draw 2 points on this graph. Let's take a look here. Let's let this point right here be x, and that point would be x comma f of x. And this point right here would be x plus h. So that point right there would be x plus h comma f of x plus h. And obviously the distance between these 2 points is h. Right, so this distance is x, this distance is h, so this distance is x plus h. Okay, and if we were to draw a secant line between those 2 points, there's your secant line between those 2 points. Okay, and the big question here is how do we make that blue line turn from a secant line to a tangent line? All right, so let's go back up here. This is the slope of that blue line. All right, the difference quotient is the slope of that blue line. But like I talked about briefly earlier here, we don't want the slope of that secant line. We want the slope of this tangent line. So how do we turn that secant line into a tangent line? Well, what we want to do is we want to make h get smaller and smaller and smaller. So let's say we moved it right here. So h is a little bit smaller. Okay, then this blue line is going to be a little bit closer to the green line. And if we move a little bit closer, it's going to be even closer to the green line until we get here. Now it's going to be really almost exactly the same as the green line until we get almost on top of it. Okay, so what we want to do here is we want to make h disappear. The problem is we can't make h 0, because if you make h 0, well, we'll have a math problem where we can't divide by 0. So what we're going to do is we're going to take a limit as h gets closer and closer and closer to 0, but never actually gets to 0. And that is how we find the slope of a function at a given point. This formula, which is the basis of half of Calculus 1, the first half of Calculus 1, is called the limit definition of derivative. What's a derivative? A derivative is the slope of a line at a point. Not slope of a line, the slope of a curve at a point. I guess it could be a line, but any function at a point. Slopes of tangent lines, so up here we have slopes of secant lines are called average rate of change. Slopes of tangent lines are called instantaneous rates of change, because it's at an instant. It's at one point. Instead of the average of 2 points, it's at one specific instant. So how do we use this? All right, let's take a look at number 1. It says use a limit definition of derivative to find the slope or the instantaneous rate of change of the curve at any point. If you see slope of a curve or instantaneous rate of change, they mean the exact same thing. Or derivative, those all mean the same thing. Okay, when it comes to calculus here. So this is a line. You should be able to look at this and know the slope of this line. Okay? Normally problems are going to be this easy, but I want to start off with a real basic one here to show you that we know the slope of this line and we're going to find it using calculus anyway. Okay? So the symbol for derivative in calculus is what you, since this is named f, the symbol for derivative is f with a little apostrophe, and we call that f prime. So that'll be read f prime of x. All right, so then we have our limit definition of derivative. Okay, so it's limit as h approaches 0 of f of x plus h minus f of x over h. And your job is to get to a point where we can put 0 in for h and not have it divided by 0. If we put 0 in right now, we're going to have divided by 0, so that's not good. All right, so let's see, what is x plus h? X plus h means you take x plus h and you put it in everywhere you see an x. All right, so we get limit as h approaches 0 of negative 4 times x plus h minus 2. That's f of x plus h. Minus, what is f of x? F of x is just a function. Negative 4x minus 2. All over h. Okay, the next 2, 3, 4, 5 steps are all going to be algebra. All right, your job now is to simplify that numerator until we can cancel out an h. And it'll always work that you can do it. So you just got to be tedious and make sure you don't make any mistakes as you go through the simplification process. Now this one's a pretty easy one because it's just a line. They get more tedious when the functions come a little bit more harder. But as you can see here, negative 4x and positive 4x cancel. Negative 2 and positive 2 cancel. So now we're left with the limit as h approaches 0 of negative 4h over h. We still can't put 0 in for h, but we can cancel these out. And now we're left with the limit as h approaches 0 of negative 4. Now there's nowhere left to put 0 in for h. Well, that means our answer is just going to be -4. So our final answer, you write like this: f prime of x is equal to -4. What does that mean? That means the slope of that line anywhere is -4. But we already knew that. The only reason why this is just a constant is because this is a line. If this is not a line, our answer will not be a constant, as we'll see when we do number 2. All right, second one. So we're going to find the derivative of g. So we'll call it g prime of x. So it's the limit as h approaches 0 of g of x plus h minus g of x all over h. All right, bear with me. There's a lot to write for this one here. So we have limit as h approaches 0. We're going to take x plus h and put it in everywhere we see an x. So 3 times x plus h squared plus 3 times x plus h plus 3. That is g of x plus h. Minus 3x squared plus 3x plus 3. That's just g of x. All over h. Now, like I said, the next couple steps here are going to be all algebra. And pretty much algebra 1, really. Your job is to simplify that numerator as much as you possibly can. Okay? So we get 3 times x squared plus 2xh plus h squared plus 3x plus 3h plus 3. And if you distribute that negative sign, minus 3x squared minus 3x minus 3 all over h. All right, doing a little bit more distributing. If we distribute that 3, we get 3x squared plus 6xh plus 3h squared plus 3x plus 3h plus 3 minus 3x squared minus 3x minus 3 all over h. I told you there was a lot to write for this one. But now, use a different color here. 3x squared minus 3x squared cancels. 3x minus 3x cancels. 3 minus 3 cancels. We're left with 6xh plus 3h squared plus 3h over h. And now I can factor out an h in the numerator. Leaving with 6x plus 3h plus 3. And if we cancel those out, we're left with limit as h approaches 0 of 6x plus 3h plus 3. And finally, we're at the point where we can put 0 in for h and not get divided by 0. So if you put 0 in for h, our final answer here is 6x plus 3. So our answer we'd write as g prime of x equals 6x plus 3. All right, we're going to go take a look at one more together here. So we want to find f prime. So that'd be a limit as h approaches 0 of f of x plus h minus f of x over h. Which would be 1 over x plus h plus 2 minus 1 over x plus 2 all over h. All right, to do this here, we're going to multiply. We're going to get a common denominator in the numerator here. So we're going to multiply this one by x plus h plus 2 over x plus h plus 2, and multiply this one by x plus 2 over x plus 2. So that gives me limit, as h approaches 0, of x plus 2 minus x plus h plus 2 over the whole common denominator, which I would tell you not to distribute that out, all over h. I'm going to put h over 1 down there, so we have a fraction over a fraction. All right, so our next step, we have x plus 2 minus x minus h minus 2 over x plus 2 times x plus h plus 2. And I'm going to flip that fraction and multiply by 1 over h. So now I have limit as h approaches 0. The numerator, all I have left after canceling out x and 2 is negative h over x plus 2 times x plus h plus 2 times 1 over h. H's cancel. So now I'm left with limit as h approaches 0 of negative 1 over x plus 2 times x plus h plus 2. At that point, we can put 0 in for h, and I'm left with negative 1 over x plus 2 times x plus 2. So my answer for this one, we can write a little summation here. F prime of x equals negative 1 over x plus 2 squared. Okay, at this point, I would suggest that you pause this video. There are 2 problems left for you to try. Try them to the best of your abilities, and then when you're done, come back and check your answers. Here's the answer number 1. Feel free to pause this video and look at this work as much as you need to. And here's your answers to number 2. Again, feel free to pause the video and check this out for as long as you need to. Tomorrow we'll go one step further and talk about tangent lines to graphs. Have a great day.